And so I have an x minus 4 times y to the fourth minus an x cubed y squared minus 3 dy dx is equal to 0. Okay. So before you sort of when you're doing this on your homework and on your test, okay, so before determining if the equation is separable or not, the first thing you want to do is solve for dy dx, right? So get dy dx by itself on one side. So you have to move this one over, so you get negative x cubed y squared minus 3 dy dx is equal to the x minus 4 y to the fourth, and it's going to be negative, right? Because you move it to the other side. Okay. Then divide this to both sides. Okay. And so you get dy dx is equal to, now since they're both negative, the negative will just cancel, and you're left with x minus 4 y to the fourth over x cubed y squared minus 3. And that's it. Okay. So I'll give you some time. Go ahead and try to separate your variables. All right, so again, it is separable, right? So obviously the dx will land over here. So this one gets multiplied, the y to the fourth gets divided, so you end up getting a y squared minus 3 over y to the fourth dy is equal to an x minus 4 over x cubed dx. Right, so these two, so this one will be divided, that's why it ended up to the bottom. This one has to be multiplied, so it ends up being on top. And then again, dy and dx are going to be over there. Okay. Questions? So now tell me, how do I integrate this one? So how do I integrate? Let's just do the left side for now, right? So how do I integrate the left side? Suggestions? Simplify to two fractions, yes. So this one is y squared over y to the fourth minus 3 over y to the fourth. Now, since I separate them, I need to put that in parentheses dy. And then same thing over here, right? You get x over x cubed minus 4 over x cubed times dx. Okay. And then what you have is a power rule. So this is y to the minus 2 minus 3y to the minus 4 dy is equal to an x to the minus 2 minus 4x to the minus 3 dx. And then now it's a power rule for each one. So this would be y to the minus 1 over negative 1 minus 3y to the minus 3 over negative 3, okay, is equal to x to the minus 1 over negative 1 minus 4x to the minus 2 over negative 2. Let's see. And then now get rid of your negative exponents. And so this basically becomes negative 1 over y. Here the 3 cancels, and then the negative makes it a positive. 1 over y cubed is equal to a negative 1 over x. And then again, this becomes a positive 2 over x squared plus c. Now, this is probably one of the few exceptions in which you do not solve for y explicitly. One, because it's difficult to do so, right? So there are 2 different y's, and one of them is to the third power, and so there is no, or I shouldn't say there's no way, but there is a way, but there's no simple way of getting your y to be by itself on one side. So this essentially is your final answer. So just make sure all the exponents are positive, so meaning turn them into reciprocals, and that would be your final answer on this problem. Questions on that? Any questions on it? All right, so now before we get into the next example, okay, we gotta talk about integration, okay? Because how do you solve a differential equation? For the most part, you integrate. So, which means I expect you to know all your integration techniques. Okay. So every integration technique, you should know them. And so, which means you should know your basic integrals. So I think there's like 16 of them. So there are 16 basic integrals, and you should know how to integrate basically all of those 16 basic functions. Now, if you don't know where they're at, you just go to a calculus textbook and then essentially flip to the back, and then there's a table somewhere that says basic integrals. So you should know those 16 basic integrals. There's actually 20 on the list, but they include your hyperbolic trig functions, and those are not really required to be sort of memorized unless you're taking engineering classes. So you don't really need to memorize those. So you should know your 16 basic integrals. I expect you to know how to do U substitution. So U substitution, you should know. Integration by parts, you should know. You should know integration by parts. Those are the two main ones. Trig substitution, it rarely shows up, but if your homework has it, then you're gonna have to know how to use it, but I don't really ask that on the test. Same thing with partial fractions. So I don't really do partial fractions on a test, but again, I can't say your homework will not have one of those. But at least for the test, I expect you to know how to do U substitution and integration by parts. Those two. Okay. Questions on the integration? Any questions on it? By the way, this is obviously not linear, right? So there's a y with multiple powers on here, so this is not linear. Okay. All right, so let me give you one to try yourself, right? So example number, what, 4, I guess? Okay. So how about an x dy dx is equal to um, a 1 plus y squared. Okay, I'm back. So you divide 1 plus 1 plus y squared on the other side, divide by 1 over, divide by x on the other side, and you get this. Okay. So how do you integrate the left side? It's your inverse tangent, right? So this is your inverse tangent of y is equal to what on either side? It's your natural log of absolute value of x plus c. And then again, since there's only one y, right, this is usually a good rule of thumb, right? If there's only one y, for the most part, you should be able to solve for it, right? So meaning you should be able to get the explicit solution. If there are multiple y's, more often than not, you won't be able to do that. But since there's only one y, I should be able to solve for that y. In this case, that's easy enough. Just take the tangent of both sides. So y is the tangent of natural log of x plus c. And there is your answer. Any questions on that? Any questions on it? Okay, let's do one more. Okay, let's do another one. So I'm not going to say anything as far as the algebra is concerned on this one. I want you to separate the variables, okay? And so because it's sort of in a weird notation. What number am I in? Number 5. Okay. So example number 5. Okay. So you have tangent x times dy plus 2y dx is equal to 0. So obviously it's a separable equation. So I want you to separate the variables and essentially solve for your function y. Okay. So go ahead and do that. So I'm not going to say anything else for algebra purposes, right? So if you do you have to do the algebra first. Okay. But I'll leave you to it. Okay, so the algebra is not bad if you sort of know how your final form is going to look like. And so you move the dx over, so you get negative 2y dx, and start dividing, right? So it's more about division. So you don't really want to add or subtract anything, right? So once you have the dy and the dx to be separate, you start just dividing. So you want to divide by y and you want to divide by tangent x. Now I'm going to leave the negative 2 on this side because I don't want fractions. So I'll have 1 over y dy is equal to a negative 2 over tangent x dx. Now, any reciprocal of a trig function, don't leave it as a reciprocal. Rewrite it using identities. And so this is negative 2 cotangent x dx. And then now integrate both sides. Okay. So the left side, we've seen plenty of these already. It's natural log of absolute value of y. So the right side is negative 2 what? What's the integral of cotangent? Natural log of sine. Okay. Let's see. All right, so now there's only one y, so you have to solve for it. Okay. So first things first, though, this negative 2 has to go, right? So you don't really want that on there. And so using your properties of logarithm, this negative 2 is going to become the power for sine x. And so the negative means reciprocal, so you're going to flip it. So reciprocal of sine is cosecant. So you now have natural log of y is equal to natural log of cosecant squared x plus c. Now, since it's squared, the absolute value is actually not necessary. And you can change that to simply parentheses. So now I want to give you some time on here because this is something we are going to see quite a bit. I want you to solve for y right now. So follow what we did a while ago, okay, and see if you can solve for y. All right, again, you can always do it one step at a time. There's nothing wrong with doing it one step at a time, okay? But again, we are going to see this quite a bit. So in some of the lectures as we move forward, I'm not going to show every step